Gospodin Gerhard Hofer iz E7 Energie Markt Analyse iz Austrije će nam predstaviti prezentaciju Opšti okvir planiranja, izgradnje i rada velikih solarnih i termalnih postrojenja sa skladištem. Floor is yours.
Thank you very much for your introduction. Good morning to everyone. Now I will like to go to a more strategic level. Now is a very good example of a solution. I would like to go to more strategic level, how district heating system could make improvements in future and could be more used in future. I give you some example of our experience, just a few examples to give an overview. What can we do to increase the use of district heating and also the use of renewables in district heating systems? First of all, I would like to introduce myself and my company. We are a small research and consultant company seated in Vienna, and our focus is on energy, and we make this on 3 different levels, so very strategic levels. So we make studies on climate change and energy economy. We also give concrete support to building owners to build sustainable buildings and energy efficient buildings, and of course we also support people, companies, building owners to save energy for existing equipments, buildings and networks. So it is more or less all 3 levels we do, and yes, this is our experience now I would like to share with you. These are some examples of our district heating experience. We'll go on a more general level, so we did some other studies and analyses for the future potential of the district heating and about the policy of special energy planning. We do some feasibility study in the city of Vienna, and they like to know what is the future of district heating on a very small scale, let's say, on a small area. Well, for Vienna it's a big area, but for Vienna it's a kind of small area. I give you an example of a procurement procedure that we did last year, 2 years ago, in a small town in Salzburg, that we said, yeah, we'd like to procure this small district heating network and also give you some experience of existing networks that you can also improve the energy efficiency and the economic situation. Okay, first of all, I would like to show you some information about our study of the future potential of the district heating in Austria, and we developed in this study, we developed a bottom-up model, and we made a grid over Austria, and this had a size of 1 to 1 kilometer, and we had 85,000 grid cells in this. And for this we had some information. We had information about the heat demand of the buildings. We know which buildings we're in, which type of buildings, and based on this information we could aggregate the energy needs of one cell, and we could combine the cell, and based on this information we could define what is the district heating potential. We had some minimum requirements for district heating, and if we are above these requirements we could say, well, this is more or less the theoretical potential of district heating for this area. And in another analysis we also said, well, what is the realistic potential of district heating in Austria, and this is more a practical approach, and we could then finally define that we have more or less potential energy demand for district heating, which is decreasing of course in the upcoming years. Buildings getting better, buildings getting refurbished, so there is a reduced demand for, or reduced potential for district heating in Austria, yes, but still we say, well, district heating is not so much covered in Austria, and still we can say, well, when we look at this information, when we look at this data, this is still a potential to grow, a realistic potential that this district heating demand, district heating supply can increase. So this is more or less the outlook for district heating companies in Austria. Well, potential is decreasing, but still you have some optimization function. You can still go to certain new areas and find some places where you put district heating. This can also be done on smaller scale. This must not be on national level, it could also be on regional level or on city level, that we have to look on the energy need in this place, and we can also think about potential improvement of the situation. Next, I will try to explain the instrument of spatial energy planning. And we made a study several years ago, 5, 6, 7 years ago, about the instrument of spatial energy planning. Spatial energy planning is that you have your energy need that you know, but you have also focused this on the area where you have this energy need, and you try to figure out which energy you can use on a special area. So you have also this local energy resources. You try to figure out which energy resources is in place for certain areas. You try to find out best potential for certain areas to use local energy resources. You also have the process to find which changes will be in this specific area in future. Are there more buildings in future? Is there a new district coming? Are houses being reduced maybe? So this is also information. So you need some information about the future development of a city, of an area. And then the major information you need and major result of it is which infrastructure do you make? Which infrastructure do you develop for certain spaces? So it is interesting to find out for which areas you would like to go with district heating, on which other areas maybe you use other resources, renewables or even gas. And this is more or less should be end in a concept for spatial energy planning, and this should be feed into the strategic urban planning and infrastructurization more or less on municipal or city level. Some examples: the Swiss people are more have more experience in this field because they have already very detailed spatial energy plan for cities and regions. In Austria, not that far. This is very critical in Austria. So the Swiss said, well, we have a plan for a city, and we define which area we use gas, which area we use heat demand, district heating, or biomass. This is really a strict plan, and every building owner has to fulfill these requirements. So there are areas for district heating, there are areas maybe for waste heat, maybe there's industry, and we can use also this waste heat from this industry, and there are energy, other energy carriers which can be used in the city. And you see in these colors, there are different colors, and for these colors and these areas, you need different energy carriers and energy use in this city. And you should define a plan for your municipality of a city to define which areas has priorities for certain energy carriers. This is more or less the spatial energy planning concept. We tried to make some studies some years ago, but still in Austria, for example, this concept is not far developed at the moment, and it is really critical to find a common agreement to do this kind of concepts. So now I would like to show you our experience in the city of Vienna. We made some awareness raising study, let's say, for the Vienna district heating supply company, because in Vienna they're also thinking, what can we do else? We have on the one hand we have the district heating, on the other hand we have gas supplied buildings. This is more or less, this covers, let's say, 95% of all buildings in Vienna at the moment. And they say, well, the current district heating system is fine. Well, they have very low CO2 emissions, they have a very good primary energy factor, let's say. But what can we do else than to use gas boilers in the city? So, and they have targets to reduce CO2 emissions. They have also targets to have fair heating rates for the residential building sector. But they want to find what could be an alternative solution to the existing gas supplied buildings. And we made a process together with the stakeholders of the city of Vienna. There is the energy department, there are some other departments of the city of Vienna, there was the district heating supplier of the city of Vienna. They all take part in this process to get more or less awareness of other solutions. The result was a good solution, but also the process to implement these kind of people to think about alternative solutions was also very important. And at the moment, they do some concepts with alternative solutions. They're not that far that they do it in a broader mass, but they are kind they're quite fit that they can do some small alternative projects at the moment. So we had a look at the city area. It's called Donaufeld. It was about 60 hectares. We have about 750,000 square meters of apartment. About 30,000 individuals should live there, and it's more or less apartment. There should be more or less apartment built there. There's also a school. But for the city of Vienna, this is more or less a middle-sized area, because this kind of area, there are 10 to 20 same areas which are same size. So this is more or less a normal area which will be developed in the next years. And so we made a process, an analyzing process, together with the stakeholders. Of course, we make this analysis. We analyze the heat demand profile of the buildings that will come. We analyze the existing potential for renewables and also the existing energy resources, which is mainly gas, district heating. It's also some kind quite near to this space. And we develop together with all the stakeholders a long list of alternative energy suppliers. So we ask them, what can you think, of which systems you can think is best to this area? And then we made some first alternative assessments. So does it really fit to this place? Does it really have enough renewables and so on? We made a short list of these options and compared this to the current conventional heating system that are used. So this is district heating and gas supplied buildings. So we made all these definitions about the calculations. So we made the economical analysis. We have to find the parameters together with all the stakeholders. And then we make more or less a detailed assessment of all these options. So we make a technical assessment. We made all these dimensions. We made all these calculations of heating loads and so on. Based on this, we make some environmental calculations, CO2 emissions, primary energy demand, and we also calculated all the costs from the initial investment and also the future running costs as well. Calculating the left side the cost of this alternative option. So this was the process, and all the stakeholders were very much involved also to this process, so that they really could feel what we are doing, and they are not surprised in the end about the results. So this was really very important that all these stakeholders we had a very close relationship during this process. And what was the basic approach? So there are many solutions we could use for these alternative solutions. There's so many different combinations of systems, but the basis was we have to reduce the temperature of the energy network. We were told before, this is very important. If available, we have to use existing heat. So if there is some waste heat at this area, we have to use it. So try to use existing heat, of course. And we have to think about all the available renewable energies that are in place. So we took more or less the solar concept and also the concept beyond the Earth, so more or less the geothermal probes. And we also try to use this for seasonal storage. So this is more or less a concept we used very much in different scenarios, but this is more or less the base concept of many of these alternatives, let's say, in different scenarios, of course. So we defined then our alternative heating supply solutions. We had the reference options, as I said before, district heating and the gas boiler. We also had some solar thermal collectors, because this is required by the building code. And the heat supply was defined in heating network and without heat network. With heat network, we also had some supply of the district heating and without district heating. So we had a broad variety of solutions. And I don't want to go into very much detail. We had some mixed concepts which use district heating, heat pumps, and solar thermal collectors. Without district heating, we had more or less a gas heating plant, and also with solar thermal collectors. And these are more or less the heat pump concepts. And they also have a peak load boiler and some solar gains as well. this was defined together with all these stakeholders and this, and then we went to the most technical assessment to find all these dimensions of these solutions. And these are some of the results I'd like to present. We have a lot of other results as well, but one is the CO2 emissions. Of course, you know, when you use gas-fired boilers, CO2 emissions is higher than the others. In the city of Vienna, we are very lucky that the CO2 emissions of the district heating is very low. You can't beat it, more or less. Well, they calculate the CO2 emissions by themselves, so this is also a way how to calculate these emissions. But still, it is well low because they lose there's a very huge use of waste heat in Vienna, so that's why. And also of cogeneration, of course, that the value could be very low. But also the values for the heat pump solutions, and also here, could be very low. This is also a good result for us that we can reduce CO2 emissions when we have alternative systems and we are not using gas. This is one of the good solutions for us, but in the city of Vienna you can't beat the district heating, which is also a solution in CO2 emissions. We also had a life cycle cost assessment. We calculated this over 40 years, and we had some definitions of the calculation parameters, of course. And you can see again, more or less, the gas-fired boiler in every building is very economical still.
Sorry about that.
No problem. So gas-fired boiler still is very economical because gas prices, as we heard, is very low at the moment. And well, if you build this, it's very an economic solution. But still, the city of Vienna says in the near future, this wouldn't be possible anymore because the requirements for CO2 emissions will increase, and you are allowed to just use a small amount of gas. So this solution doesn't have any future, let's say. This other solution on the left side is district heating, the existing district heating. And we could find that the heat pump concept has a quite good result in comparison with the district heating. So they are in the same range, let's say, as the district heating solution for this area, for this specific area. We don't have this huge area space to use this big dimension of solar thermal concept that is presented before. This is not quite near, so this is for this area, my point of view, another good concept, but we can use more or less the geothermal energy, and this is very attractive economically. Not best, but still quite good. Okay, this is more or less one main result of our study in this area. And next I would like to show you a procurement process of a smaller heating network. It's a district heating, it's a local energy, local heat network of one building developer. This was developed in the small city of Salem-See in Vienna, and this we also have to develop the heating system concept, and we have the obligation to build photovoltaics on top of the buildings, and they have the obligation to use this for the heating system. So there are some requirements because it's a subsidized concept. The federal government of Salzburg is subsidizing this concept, and they have some requirements, let's say, so on the energy demand of the building, on the photovoltaics level, and so on. And everything has to be in the overall concept of the heating system. And this was a smaller project, it was a private procurement procedure, so it was not a big traditional public procurement, it was a smaller one. At the end, it was a competition between 3 companies who would like to supply this area with energy. The scope of the heating supply concept is that they make the concept, detailed planning, installation, and also financing of this concept, and also the operation also think 20 years. This is all part of the tendering process. So this is smaller. This has about 20,000 square meters gross floor area. We have 23 buildings, about 500 individuals, 0.7 megawatts of power, and also mainly apartments, supermarket and kindergarten. And this will be constructed, I think now, at the moment, and will be operated, so, well, beginning of 2020. So this is construction phase. Should be earlier, should be next year, let's say. The operation should start at the beginning of the 2020s. And we defined, based on the requirements of the federal government of Salzburg, we defined somehow more or less a heating concept, but not of the central heating areas, but on the decentralized heating concept on the apartment. They have some ideas which solution should be made to the apartments. They have some requirements on the temperature of the heating system, but still the central heating concept the competitors have to define. So this was more or less a competition of ideas. So which idea do we have to define this central heating concept? You have to have more than 90% renewables, and you have to integrate photovoltaics. This is more or less the ideas, the requirements, and we asked for ideas. And we get really good results. We get really some innovative experience out of this competition. The heat tariff for the building owner, building user was more or less fixed in this concept. And they have to calculate, so what is the additional investment we have at the beginning of the project by the project developer. And the one with the best idea and the lowest initial investment cost was the winner of the concept of the competition, and it was quite, well, practically speaking, it was more or less a small biomass district heating concept in the end, with a huge amount of photovoltaics on the top of the central heating buildings, and also with a smaller heat pump system to cover all this electricity. So that this was more or less the basics of this final, the winner of this competition. So, at the end, some experience or some outlook of our experience to existing network, because many district heating plants are built, many district heating networks are built. So what to do with existing networks? And we will start actually with some analysis to reduce the temperature, the inlet temperature of district heating network. For this, we have to analyze, for the first example, this hospital building. We have to analyze all the processes in the building. Which processes have to change to reduce the temperature of the temperature of the district heating, the local district heating. So when the first example there, or the second example, at the moment they still use a steam heating network, so very high energy, very high temperature, and they like to reduce this to 90 degrees maximum. And you have to analyze all the processes in this building, how to reduce the temperature. So you have to look at every single process to the building where they need heat at the moment and track how we can go down with the temperature. And this is, well, the task in the upcoming future, to make a concept that really heating network can lower the temperature to be more energy efficient and also more have a better economic performance of the heating system. Okay, this was an overview of my side. Thank you for your attention. If you have any questions, feel free.
Thank you, Mr. Hofer, for this insight in how you plan your energy systems in Austria. So, da li imamo pitanja? Imamo, gospodin Macura.
Just a short question, Alexander Macura. Are there more details on the methodology somewhere on the web so that we don't waste time here. Do you have more details on the methodology of the planning somewhere on the web, on the internet available?
Which example do you mean?
For the start, the first one, the planning concept, the potential for district heating, the first thing, the spatial energy, spatial.
I'm sure there's a report on the website, but I can also send it if you give me a visit.
Oh, if there is on the website, we will find it, just not to waste the time.
Still a long time ago, you know, this is from the early 2010 years, so...
If we don't find it, we'll send you an email.
Yes.
So thank you.
Otherwise, please send me an email, yeah, you're welcome.
Thank you.